Welcome again to our latest installment with St. Emily's Math. Again, we're looking at the problem of the week for the grade 5-6s from the Center of Education, Mathematics and Computing. And the problem this week reads, Cool Cole has been building his robot Robbie for the big 4-meter drag race. He's learned that his robot moves 75 millimeters in a straight line every time its tires do a full 360 rotation. He programs Robbie to do 50 tire rotations for the race. So the first question starts off and it says, Robbie is 25 centimeters long. If the race starts with the nose of the robot touching the starting line, will the nose of the robot get to the end line of the drag race after 50 rotations? This particular question, when we first read it, it's a little tricky to kind of figure out what is it it's actually asking for, and that's always where we want to start. We need to understand the problem. So in this particular case, to understand the problem, the first thing we realize is we've got a lot of different conversions here. We're dealing with millimeters, we're dealing with centimeters, we're dealing with meters, and again, when we think about our number lines, we can use our number lines to kind of solve this. So if I understand here, on my first number line I'm dealing with meters, and I have a 0 to 1, that same number line is going to represent 100 centimeters, is also going to represent 1,000 millimeters. And so when I look at the first one, when it says 75, when he learns that this robot moves 75 millimeters in a straight line, again, if I put my 75 there, I quickly realize that my 75 millimeters is the same as the 7.5, and it's the same as the 0.075 meters in this particular case. The second thing that's important to recognize, though, is it makes it sound like we're dealing with degrees and circles and so on, but in reality we're not. This is why it's a linear measurement, because when we think about a tire, absolutely the base of the tire is going to be round, but we're not measuring the base, we're actually measuring the side. And as we know with a cylinder, which is what a tire is, we know that we're actually dealing with a rectangle, and so we're still dealing with linear measurements. And that's the part that we need to understand through this question. And so the second part then, how many complete rotations will the robot's tire need to do in order for the entire robot to completely finish the finish line? Again, we're going to use one of our robots that we've been building here at St. Emily's, and when we recognize that as our robot is moving, again, in reality, we are simply dealing with one rotation is going to be one rectangle. And so, as we continue to go through our rotations, we know that we're simply doing a linear measurement. Thank you very much, folks. We'll see you next week.